Well, today we'll be focusing on one aspect of statistics, which is to determine the range, interquartile range, semi-interquartile ranges for a set of data. That's what we'll be doing. Determine determining the range, interquartile range, semi-quartile range for a set of data. And the calculations are pretty manageable, and you should enjoy them. Now, let's say that you are asked to calculate. So let's look at question 1. You're asked to calculate the range, interquartile, and semi-quartile ranges for the following set of numbers below. Good. And these numbers are 1, 2, 2, sorry. These numbers are 2, 1, 4, 5, 6, 4, 5, 8, 9, 3, 3, 1, 4, 4, 2. A set of 15 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15. Good. The first step is that you're going to arrange these numbers in ascending order. In order for us to find the range. So arrange the set in ascending order. So that will work out to be 1, 1, 2, 2, 3, 3, 4, 4, 4, 5, 5, 6, 8, 9. I think we missed out one. 1, 2, 2, 2, 3, 3, 4, 4. We missed out a 4 here. Good. So we should have 15 numbers, 15 items. Good. So the range would be here. The range would be the difference between the highest and the lowest object. And that works out to be 9 minus 1. Pretty simple. Good. Our next step is to work out the interquartile range, which is usually reflected by a formula, and the formula can actually be predicted. So let's do it at the top here. Our aim is to work out the interquartile range. So part 2. So the interquartile range is basically the upper quartile minus the lower quartile, which is pretty much Q3 minus Q1. Good. So the interquartile range is equal to the upper quartile minus the lower quartile. Remember the set of data is divided up into quartiles. Good. And you have the median, you have the upper quartile, the lower quartile, the median. So the interquartile range is actually the difference between the upper quartile and the lower quartile. And we usually represent it by using Q3 and subtracting that from the lower quartile, which is normally written as Q1. So essentially, this is really the third quartile, n plus 1, or 4 minus the lower quartile, which is a quarter of that, n plus 1, where n is equal to the number of objects or elements in the data set. So let's look at the upper quartile. Let's consider the upper quartile. Which is Q3. That will work out to be, we need to find what n is. So that will be equal to that we put back the numbers that we arrange in ascending order. So we can see what's happening, that we had 1, 1, 2, 2, 3, 3. There are 4 4s. 5. Have another 5. We have a 6, an 8. We have a 9. That should be 15. 1, 2. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, good. So we can then find the upper quartile, and that will be 3/4 of the number of objects in this set, which is 15 plus 1. And that will work out to 3/4 times 16, and that will give us 15. That will give us 12. Right? Now, what we need to do is to then find the 12th object within the data set. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's go again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that works out to be 5. So the upper quartile there is, so Q3 is equal to 5. Now we can then find, the lower quartile. We can then calculate the lower quartile using the same principle. So the lower quartile, so that will be equal to 4. So we can write back our data set that we had written in ascending order, so that we can find where is the lower quartile located in the group of in the set of data. Good. So we will count 4, so that will be 1, 2, 3, 4, so that will be 2. So therefore our interquartile range will be equal to, as we see before, Q3 minus, let's do that better, Q3 minus Q1, and we have found them. We had found earlier that Q3 is 5, and we have now found that Q1, which is the lower quartile range, is actually 2. So therefore, the interquartile, so our interquartile range, represented by Q3 minus Q1, and we had found Q3 to be 5, and we have now found that Q1, which is the lower quartile range, is 2. So the interquartile range here is actually 3. Good. Now, how do we find the semi-interquartile range? So the the semi-interquartile range is pretty much half of the, in order for us to find the semi-interquartile range, is actually 1/2 of the interquartile range. So that works out to be 1/2 over 3, and that works out to be 3/2. Good? Now let's try another question. The following set of marks was obtained from a mathematics end of month quiz. Calculate the range, interquartile, range, and semi-interquartile range. The data set is as given: 20, 28, 40, 12, 30, 15, 20. So it's 20, 28, 40, 12, 30, 15, 20. Okay. So here we have 20, 28, 40, 12, 30, 15, 20. So first thing we need to do again is to arrange these in ascending order. So that would be 12, 15, 20, 28, 30, 40, 50. And then we can find the range. The range will be the difference between the highest object or element and the lowest. And that will be 50 minus 12, which should give us 38. The interquartile range would be 3/4 of the number of objects, the product of the number of objects plus 1. And that will be, you'll find the difference there with your lower quartile. So this one here will be Q3, this one here will be Q1. You're basically finding the difference. How many number of objects that we have here? We have 1, 2, 3, 4, 5, 6, 7. We have 7. And similarly, we have 7 there, so that will give us 3/4 times 8 minus 1/4 times 8, and that works out to be 2, that gives us 6 minus It gives us 6. Hold on. We should have work them out individually and then find where in the set is the quartile, the lower quartile and the upper quartile first. So here we have the answer here is actually 6. 1, 2, 3, 4, 5, 6. So that's 40. And the other one here is 2. So that's 1, 2. So that will be minus 15. And that will work out to be how much? 25. And then you can try to figure out what the semi-quartile range would be, semi-interquartile range. And it's pretty much 1/2 of the interquartile range. So that's it for this subheading. See you next session where we continue the lesson on statistics.